Hey everyone, thank you for being here today. I have to say, you look amazing from here. My name is Emiliano Della Casa. First of all, sorry for my voice, but too much karaoke last night. And yeah, loud Kaiser Chiefs, sorry. So today, we are going to talk about gRPC. So I saw there is a lot of people that have heard of gRPC, but how many of you have really used in production? Okay, that's good, quite a few. Well, gRPC is a communication framework that was firstly announced by Google in 2015, and a few months later, it was released as an open source project on GitHub. And it's basically a communication framework for heterogeneous systems and different architectures. It supports multiple languages. So from the very beginning, it was released for many languages like Java, C++, Python, and of course, also Ruby. And it's really high performance, supports different languages, as I saw. It's strongly typed, and it supports from the very beginning also advanced security. gRPC supports 4 types of communication. Unary, when the client makes a single request and the server responds with a single response. Client streaming, where the client streams data and the server responds with a single request. Server streaming, when the client sends a single request and the server streams. Or bidirectional. That is quite cool. Now, as its core, gRPC stands on 2 pillars. The first one is HTTP2, that for sure everyone has heard about it. It's just an improved version of the HTTP protocol to overcome some of the performance limitations that HTTP protocol had. So it has multiplexing of single connection, HTTP header compression, server push, request prioritization, and binary transmission. The other pillar is protobuf, and that could be like a more mysterious part of the protocol. What? I lost it? Okay, never mind. Okay. Protobuf is basically a serialization mechanism, and it's language and architectural neutral, and supports strong typing, and it's backward and forward compatible. And this is really, really interesting, as we are going to see. Now, let's see. Do you, oh, okay, it's fine, okay, you should see. Okay, this is a really simple proto file. You can see we are defining the syntax. We are defining a package that is just like a namespace. And the basic structure is called a message. Here, we are defining a person message that is an object with 5 fields. So we have, for example, ID in first position is number 1, of type int32. Then we have name, surname, email at second, third, and fourth position. And then we have 4 numbers of type strings, but with the repeated, we can say it's like an array of strings in 5th position. And what is really interesting is that starting from this file, we can generate with a compiler called proto-C the serialization and deserialization classes for both the server and the client. Let's see how it works. In Ruby, we have gRPC tools Ruby protoc. We are using the I parameter to include all the proto files in the protos directory. Then with the Ruby out parameter, we can say how we want the Ruby classes to be created. And we just specify the proto file. Actually, we don't receive any output at all, but as you can see, a people pb rb file was created. Let's take a look at it. As you can see, it was automatically generated, and it has some weird data over there in the descriptor data, and this is just a serialized representation of the message. It's important to say you don't have to modify this file because every time you run the compiler, everything will be overwritten. Now, we have seen the classes. Now we are going to see the functions. And to define a function, we need to define a service. In this case, it's people service. And the function is specified by the RPC directive. So in this case, we have a getPerson function that is taking a message called person request that is defined below, and returns as an output a person message that we have just seen. Now, if we run the command again, same thing, just this time we also have to add another parameter that is called gRPC out. Don't ask me why it's different because it's basically producing the same Ruby code. But anyway, it's just like that. And also, this time, we won't receive any output at all, but a new file will be created. Let's take a look. That's it. Now, if you take a look at that, we can see that basically it's defining a people module, a people service module that was defined in the proto file, and we can specify how to encode and decode the message, and the getPerson function is over there, taking person request as input and person as output. Also, in this case, you don't have to change this file. Now, as I said, gRPC is backward and forward compatible, but you have to follow 4 simple rules. Rule number 1, you don't have to change the number field. So if you have ID at first position and name at second position, you cannot switch it. Rule number 2, you can add new fields, but with unique numbers, meaning the same number cannot be used in the past. As a consequence, you can remove fields, but numbers cannot be reused. As a 4th rule, fortunately, some data types are interchangeable. So you can change, for example, int32 and int to int64 without any issue. I mean, you can change, you can not follow these rules, but I mean, YOLO, it's up to you. Now, let's take a look at a simple example, simple application using gRPC. Let's say we have an e-commerce application, we have a customer model, a product model, and an order model. We are creating customer A with currency euro, customer B with currency dollar, and 2 products, product A with a price of 1,000 cents, and product B with a price 2,000 cents. We are defining an orders proto. Over here, we are defining an e-commerce package with a create order function, I mean service, RPC function, taking a create order request, specifying customer ID in first position, product ID, and shipping address. And as an output, we receive the order ID, the total, and the currency. Pretty easy. Then, in our Rails application, we just need to add basically one gem, gRPC gem. This is required for creating the server, for starting the servers. If we add gRPC tools, basically we are going to get just the proto compiler we just saw. Then we need to create an initializer file like this one to start the server. As you see, we specify the port, so our server will listen on 0.0.0.0 50,051, and we're starting the server, and we're instantiating the server and starting on our port. This is just the order service we created with the protocol file. As you can see, we have a create order with the create order request and create order response. And this is where it gets more interesting, because as I said before, we cannot change the service file. So in this case, I'm creating an order service RB file in let's say in a services directory that is inheriting from the file we just saw. As you see, e-commerce order service. So we are inheriting from that one, and we are adding a create order function, taking the request as a first parameter. And that the code is quite simple. We're getting the customer from the customer ID, we're getting the product, we're creating an order, and as a return of our function, we need to instantiate a create order response with our order ID, total cents, and currency. And that class, that object, will be serialized and sent back to the client. But for the gRPC to support the new service, we need to add it with the handle function over there. Now, we create the database, we run the migration, we run the server, and we see for line that our server now is actually listening on the gRPC port. Now, let's see a comparison. On the left side, we're running the server. On the right side, we are using gRP curl, that, as the name says, is just curl, but for gRPC. The command is quite long, so I just paste it. But if you see the payload, in the first case, I've had the customer ID number 1, product ID number 1, and I got the order ID, the total cents, and the currency, according to the customers and the product. And in the second case, I just changed the product ID and the customer ID, and the response was fine. So, pretty easy. Now, you're going to ask, okay, have you ever used in production? Yeah, actually, I have. One of my customers runs a pretty big fleet tracking application. The web application is written in Ruby on Rails, but the backend is in Node.js, unfortunately, on an AWS Lambda stack. And we have like 10,000 tracking devices right now. And the funny thing is that it started as a snowplow tracking application. You know, Italy is that beautiful country going from nice weather in Sicily to snowy winter in the north. And in peak days, we can reach up to 55 positions, or well, it's better to say invocations per second when it's snowy. And you don't have any word at all, so you have to be really scalable, really fast. Now, the business need that required gRPC was because the devices keep the connection open when they send the position for a short while to receive information, to receive commands. But we wanted to keep the business logic as much as possible on Ruby on Rails to avoid code duplication. And of course, we have to keep connection as short as possible. So this is real data from last December. Maybe you're not aware of it, but the 8th of December in Italy is actually a holiday where everyone is drinking hot chocolate, watching out of the window the snow falling, and I was watching graphs on AWS. So we just went from almost 0 invocations to 56,000 per hour. And on the right side, you're going to see the CPU of utilization of the gRPC container and went from 0 to 12%. That is quite a good result. And based on our data, the response time average was between 7 milliseconds and 15 milliseconds. So today, we learned a little bit of history of gRPC and the basic concepts. We saw how HTTP2 works and protobuf works, and we saw how to add a gRPC service to a Ruby on Rails application and how it works. Thank you very much.